All right, we are now on part 2 of the endocrine system, and we just got done talking about how the parathyroid and the thyroid help keep our blood calcium level constant. And we're going to see why that's important later in the course. But we call that homeostasis, and all of these glands help us maintain homeostasis. It's the purpose for the endocrine system. But there's two different ways we can maintain homeostasis, and they're called feedback loops. So, number one is called a negative feedback loop. Negative feedback loop. Over the course of this course, we're going to look at a couple of negative feedback loops. So, if you would imagine in your home, you have a thermostat and it's got a scale here, and there's a little dial. And let's say this center is 72 degrees. Well, as this goes up, your air conditioning is going to kick on. It's going to pull it back to center. And as it gets colder, your heat's going to kick on and it's going to pull it back to center. This is an example of a negative feedback loop where we're constantly pulling a homeostatic value back to a central point. So a calcium cycle is an example of a negative feedback loop. Here we're going to pull our value back to center. And so our calcium cycle is a good example of that. We're also going to see our blood sugar is a negative feedback loop. Gosh, what are some of the other ones we're going to do? Almost all of your electrolytes, sodium, and other values. Now, on the opposite side of the spectrum, we have what's called a positive feedback loop. Positive feedback loop. An example of this would be childbirth. So you start off in childbirth and you have a contraction, and it's kind of small. That contraction causes hormones to be released, and it causes the next contraction to be larger. And that next larger contraction releases another a spurt of hormones that causes a third contraction to get stronger. And this continues in amplification until the child's born, and then boom, it's done. We return to homeostasis. Positive feedback loop, we have amplification followed by a quick reset. By a quick reset to homeostasis. And a good example of that is childbirth, i.e. childbirth. So we talked about the thymus in the lymphatic video, so I'm not going to talk about that one, but let's talk about the pancreas right now. And I'm going to do this guy in pink. So pancreas we'll do over here. The pancreas is both an endocrine gland and an exocrine gland. So we're going to see in the digestive system how it functions. This is endocrine and exocrine. But what we're talking about here are its endocrine functions. Dotted all over the pancreas, let's see, right here's your pancreas. These dots are called islets of Langerhans. And these function in the negative feedback loop control of your blood sugar levels. So these participate in, I'm going to put NFL, negative feedback loop control of blood sugar. So these little dots are the endocrine glands, and the organ itself. Let me outline this. It's a little bit hard to see. So here's the outline. The rest of the pancreas is the exocrine gland, and we'll talk about that later. The hormones that are released are insulin, which lowers blood sugar, and glucagon, glucagon, which raises. So again, we're back at that. If we're high, we're going to release insulin, bring it down. If we're low, we're going to increase glucagon, and that's going to raise our blood sugar. And if you know anybody who has diabetes, they have an issue with blood sugar. There's different types of diabetes. Again, more to follow on that later. But if you have diabetes, then you have issues with this. All right, we talked about the testes and the ovaries. That just leaves us with the adrenals. So these adrenals, those sit on top of the kidneys. So they're found on top of the kidneys. That's where they're located. And they have a role to play in stress. So when we are stressed or under duress, these adrenals release two compounds. They release cortisol and they release epinephrine. Epinephrine gets turned into adrenaline. Have you heard of this before? Everybody has. You know, the term adrenaline junkie. So adrenaline is what increases our automatic responses in our body, increases our heart rate, increases our blood flow. We get this surge of energy. Cortisol shuts off our non-essential body functions, like digesting our food or metabolism. So between the two, the epinephrine, the adrenaline gives us a boost. The cortisol kind of shuts everything else that's not essential off. Well, if you're being chased by a tiger, this is a good thing. You really need that extra energy, and you need to, shut off everything that's not essential. But what if it's taking a test? What if it's that you're in a fight with your best friend? Your body's going to react the same way. Your endocrine system in your brain isn't all that smart when it comes to sensing your environment, and it really can't tell the difference between a test stress and being chased by a tiger. So the result is we in our higher stress environment in today's society are in a constant kind of state of adrenalization. We're constantly pumping this stuff out. Well, if you're shutting off your metabolism, your digestive system, it's going to shuttle all of your carbs and energy into fat. That's why people who are stressed have a really hard time with their weight, because they're putting out cortisol all the time. They tend to gain weight. So the moral of the story there is try to deep breathe, try to relax, don't get too stressed. All right, so what are our takeaways on the endocrine system? We started off, we said that we have endocrine versus exocrine. Exocrine we're going to secrete into a duct or the surface, but endocrine goes into the blood or tissue for the purpose of maintaining homeostasis. We can do that for two ways: negative feedback loops and positive feedback loops. We looked at two examples of negative feedback loops. The parathyroid is going to increase the calcium. The thyroid is going to lower our calcium. The pancreas, the islets of Langerhans, have a negative feedback loop. Insulin is going to lower our blood sugar. Glucagon is going to raise our blood sugar. These are controlled by the pituitary. The pituitary is going to shut these off and on. Then we have our sex hormones. The testes and the ovaries, those are going to produce the hormones that we need to develop into male or female. And then finally, we mentioned the pineal, which produces melatonin, and the adrenals that produce cortisol and epinephrine. All right, that is a good kind of overview of your endocrine system. And we're getting close to wrapping up this chapter. All right, thanks for watching. That's all for now.